Okay, so let's do some more examples. And what we're going to do now is we're going to do systems of inequalities, linear inequalities of two variables. Now, there's actually no difference between what we did in the very first problem and this one right here. So what you're going to do is you're going to separate them into two problems, solve them separately, and graph them separately. And the solution set will be the part of the graph which is overlapped. So let's go ahead and do the first one on the left, which is fairly straightforward. Subtract 1 to both sides. So we get y plus x is greater than negative 1. And then subtract the x as well. So what we end up with here is y is greater than negative x minus 1. So again, this is going to be a two-variable inequality, where we have the y value or the output being above that line. So let's go ahead and solve the other one, and then we'll graph that, and you can see what the solution set should look like. So here first, we're going to divide by 5 over 3. So these cancel. And what you're left with is y plus 5 is less than or equal to, when we have division by a fraction, they flip, and then multiply to the top. And then lastly, subtract both sides by 5. So we get y is less than or equal to 3 over 5x minus 5. So the first line, and I'll do that one in green, it's given by negative 1, so it starts here, and then it goes down, sorry, that's not 1. Negative 1. And then it goes down 1, right 1. Down 1, right 1. And remember, this is a greater than, so we don't have a solid line, it's going to be dotted. If you want to do that after as well, the way we did it previously, where you just erase it, that's also fine. And we want the heights above. So let's go to the line and draw our lines up, because that's the things that are above. Now for the other, let's do it in orange. And so we start at negative 5, which is down here. And then we go up 3, right 5. So 1, 2, 3, right 5 is all over here. This is going to be a solid line because of the or equal to here. And we want it to be less than. So if we go to the orange line, and we draw our lines down, because that's the parts where the height is below, we get that. So can we see here that the overlap of these two lines is given by this triangle here? And don't forget, it tends out, continuously out towards infinity. So our solution set is actually that part which satisfies both of these inequalities. So what we're going to do now is we're going to do a special case, just so you can see that we have different types of solutions, not just the one that we saw on the board. So this is going to be a very straightforward example where we have y is greater than or equal to 2x plus 1. And then y is less than or equal to 2x minus 1. So it's already solved for, so we can go ahead and graph this right away. And so let all these tick points be ones. So let's do the first one. It starts at 1. Goes up to right 1. And again, if you have 2 points, you can already draw the line. So it looks like this. and we want it to be above or equal to. So solid and above. The green one is 2x minus 1, which starts here, goes up 1, right 1. And we want all of those which are below or equal to, so solid line and all the lines below. But notice that there's no overlap in either of these equations. So this set of linear inequalities of two variables has no solution. Okay. In this last example, we'll do one where there's 3, and there's a little bit of a difference in this third example, because instead of just having the y is less than or greater than some sort of x value, we're also going to have one with just x's, so you can see what happens. So x minus y is less than 3. Negative 3 is less than or equal to x, which is less than 3, and then y is less than 3. So again, fairly straightforward examples, because can we see that the two on the right hand side are actually done, right? There's nothing for us to do. But the one on the left here, we can solve this one by bringing over the x. So we have negative y is less than negative x plus 3, and then multiplying both sides by negative 1. And anytime we multiply or divide by a negative, the inequality flips. So y is greater than x minus 3. So with all three of these, let's go ahead and graph them. And the first one, this y is greater than negative 3, x minus negative 3. Is fairly straightforward, right? We start at negative 3, we go up 1, right 1, and then draw our line. And this is a greater than, so we do not want it to be solid, we want this to be dotted, and greater than means above, so draw our lines going above. Okay, the next one here, there is no y value, but it's asking you to create lines or a bound for the x value. And the x values, negative 3 to 3, are right here and here. So the x values which are between those are these ones. Whereas, for example, x is greater than 3, can we see the x values which are greater than 3 are to the right of this line. So if there's just an x in a 2-variable version, you're going to have vertical lines, and you need to determine it based on left and right instead of up and down. So this first line is the x equals negative 3 line, and this one is solid because of the equal to sign here. Whereas the one on the right, the x is equal to 3 version, doesn't have, is less than 3, doesn't have an equal sign, so it's going to be dotted. And again, the parts that are in between are all of those. And then lastly, green, y is less than 3. So again, these are heights that are below 3. So the height of 3 is right there. And all the parts which are below it are going to be underneath. Now remember, the part that is the solution is the part where all of them overlap. So can we see that there is only green and black here? There's only black here, there's only green here, there's only green and orange here. But right here in this middle part, where it's this triangle, from this green line to this black line up to this orange line, that has orange, green, and black inside. So our solution is really this part of the graph. Okay. So it is very useful to use multiple colors. If you do not have multiple colors to use, I usually draw two of them in different directions. So like this one where it's up and down and then left and right. And then the third part, I use some sort of shape. So I'll fill in this part with like circles instead. And the part which is the solution set would be the part that has the left, the right, and the circles. And I think that is fairly easy to see even in that picture.